Welcome back to another lesson. We have already introduced tables of logarithms, seen how they are made, and how they can be used to convert multiplication and division into addition and subtraction, respectively. If you missed those lessons, it might be worth your time to check those out and catch yourself up to speed. Today we're going to see how log tables can be used to find logarithms, exponents, roots, and powers. Let's start with base 10 logarithms, also known as common logarithms. The common log of 4.837 can be found by pushing a few buttons on a scientific calculator. That answer is shown in the first line. In the second line is the result we obtained by looking up the value in the table. Notice it is accurate to about 4 digits. Matching the color coordination on the previous screen, this is how we find that answer. At this point, it will probably make more sense for you to look and digest rather than me talking about it. Pause the video and go back as necessary until it makes sense. Pull out your own scientific calculator and compare your answer to this. What if the base of the logarithm isn't 10? What if we wanted to know the base 3 logarithm of 4.837, for example? Using our change of base expression, we would need to divide the two logarithms. The middle line shows the computation from a scientific calculator. The last line shows the result from using a log table. We just saw the log of 4.837 in the last example, so all we need to do is look up the log of 3 and then divide. The common log of 3 is boxed in orange. It corresponds to the example on the previous page. By the way, this is a situation in which you might need to know the base 3 log of 4.837, solving for a power n. Because we only rounded to 4 digits, notice there's a bit of rounding error in the last digit. Now let's look at base 10 exponents. We can split up the exponent into 3 and 0.651. The answer using a scientific calculator is seen on the last line. If we use log tables, we get the same answer, rounded to 4 digits. Take note of the green and blue underlines and how these show up in the table on the next slide. 6510 is not on the table. However, it equals 6503 plus 7. These are boxed in green. The numbers underlined in blue correspond to 4.477. What about exponents with a base other than 10? We've seen this example of 2 raised to the 3.761 a number of times before. Using the log and exponent functions on a scientific calculator, we get the answer at the bottom of the left column. To solve this using log tables, we follow the right-hand column. The process is identical. We just round to 4 digits, actually 5 digits in this case, which I will explain shortly. 2291 is not in the table. However, it is the sum of 2279 and 12. 12 is not in the right side of this table, but 11 and 13 are. We can split the difference. These numbers are boxed in green. Corresponding to these values are those underlined in blue. Thus we get 1.6945. Go back and look at the previous slide to see how these numbers were applied. Log tables can also be used to find roots. We will start with square roots. A built-in function on a calculator, or Newton's method, will give the square root of 5 as 2.236. To take square roots, divide the log of 5 by 2, then perform a reverse table lookup. That gives us 2.236. Once again, 3495 is not on the table, so we take 3483 plus 12, all boxed in green. These correspond to 2.236. Those numbers are underlined in blue. Same idea for any other root. To find the cubic root of 8, for example, find the log of 8 in the table, then divide by 3. A reverse table lookup gives us 2.000 exactly. This was what we expect. Perfect. This is the portion of the table applicable to the reverse lookup. Hopefully by now you are getting the hang of it and can do some of these on your own. For the last example, let us consider the reciprocal of a number. Punching 1 divided by 7 on a calculator gives 0.142857 repeating. To find this on a log table, we take 1 minus the log of 7, which is 0.1549. A reverse table lookup gives 1.429. But then we divide by 10, which moves the decimal once to the left. This is what that looks like on the table. Notice that 1549 is 1523 plus 26. Unfortunately, 26 is not on the table, so I had to pick 27. Within rounding, this gives us the correct answer to 4 digits. I realize I haven't shown the full table in this lesson. If you would like that, refer to my other lessons on log tables, or search for one on the internet. This is a fairly easy resource to find. To summarize, all the buttons boxed in red represent operations that can be done with log tables. Including the inverses, that is 12 operations by my count. Not too bad in the ages before electronic calculation. What do you think of all this? Let us know in the comments section below. Also, feel free to ask any questions needed to enhance your understanding of this material. Thanks for watching. I look forward to seeing you again.